Hello all, welcome back to my third series on the Formula 1 technical videos. In the last series I'd intended doing a video on the Formula 1 engine scavenge system, but sadly it's going to take a bit of time to get the parts together and all that. So I've got parts here and they're the hydraulic system, so we're going to do that video instead. So everything on a Formula 1 engine is controlled with hydraulics. The gearbox, the intake system, the clutch, the power steering, all that is controlled with hydraulic power. Now, hydraulic power is used because basically because of power to weight ratio. If you had a electronic sender or electronic solenoid or sensor like that, or electronic actuator, in terms of power to weight ratio, hydraulic wins every time. You know, it's the actuators are very lightweight compared to, like, if you had an electronic coil and all that on the back of the sender, it'd be very heavy. So hydraulics is the best way to go. So here we have two pumps off. They're actually off the last of the Honda engines. I think they were Honda V8 or V10. I'm not quite sure. Now these are made by Parker Hannifin. They're a very common pump with F1 engines. They're used also in aerospace, in aircraft. I mean, they're in a huge amount of aircraft. They're in the, off the top of my head, they're in the 747, the 777. I think the Cessna. They're actually in the F-16 as well. Would you believe it? So they're a very common pump made in the US by Parker Hannifin, which you can probably see there. Hopefully you can see the part number. Now they're both the same. Now obviously this is different because it's got a, what we call an accumulator on the back of it, which we'll go into later. But again, they're very small. In terms of what they can do, they're amazing pumps, you know. Now, as you can see, there's different mounts here. This one I think was off the V10. This was the V8 part later on. As you can see, the accumulator housing, amazing part. Billet machined, or machine for billet, should I say. It's probably 2 or 7 series. It's got all the blanks in there, but a fabulous part, you know. What a finish, right off the CNC machine. Hardly, there's one tool mark there, very slight, but epic, you know. So what I'm going to do is I'm going to talk you through these pumps. They're both the same. We can probably discard that one in a moment and take apart this one, explain how it works, and we'll take it from there. So this would go on the, this is driven by the engine, obviously. Now this pump in my hand here, for one turn, you can see the shaft here. It's driven off a, it's actually driven on the, it's the same in the Cosworth as well, actually, the Cosworth TJ and the Cosworth CA. It's driven off the back of the alternator, would you believe it? So you'd have the water pump here, alternator, and it's driven up the back of it with a spline shaft, which you can pull out there. Now you'll notice, just talking about the shaft first, we'll get rid of that then and concentrate on the pump. You'll notice the little nylon part on it there on the end of the shaft, on the end of the spline shaft. That's to control under braking and acceleration, where the shaft would be in here. As you can see, when you brake and accelerate, the shaft would float slightly axially. So that just protects the pump from the shaft, you know, fretting off it that way. So that's a nice feature. Hopefully you can see it there. It's just an nylon button pushed in the end. Very cool. Again, every Formula 1 part has a part number. They don't mean anything for this video, but it's there on that. Hopefully you can see it. Again, lovely clean hands. Not. So we leave that aside, and again it's the same shaft again for this. they're all the same, you know. Now what's different is the mounting brackets. This was mounted on elastomer bushings, so it would allow a bit of compliance to vibrate and all that, and mounted on O-rings here, but we'll leave that aside for a moment and just concentrate on this one. So how does this pump work, or what is it? Well, a lot of you are familiar with, I guess, normal hydraulic pumps, which would be a log splitter or something like that. Even on your tractor, you know, driving various things, table saws and all that, they normally work with gears, which would be common in your engine oil pump. You know, the basic oil pumps, which would be just, you know, 2 gears like that, in mesh. It pulls the oil in here, around the edge where the teeth are, and it puts it out here. That's fine, but that's constant displacement, which all the time it's pumping the same volume of fluid, no matter what's going on out here on the demand side. But this pump is different. It's a variable displacement Swashplate pump, which is very cool, which we'll get into in a moment, and I'll show you all the bits. So before we start taking it apart, as I said, this housing here would bolt on. Now they're both different, but this would bolt on to the back of the alternator. This is bespoke. The pumps are the same, as you can see. They're the same main chassis and all that. I'll just put that back in there. I'll show you that in a minute. But the mounting is different. So what I'll do is first, I'll pull off this mounting, and we'll talk about how it's mounted to the engine, and we'll see what's going on there. So I'll do it on camera. There's going to be no edits in this video, no stops, hopefully, and all that. So it'll be just one pull. So we'll see how we go. That keeps falling out. Right, so we start taking it apart. So this mounting, as I said, is how it mounts the engine. We'll just take that off there. You can just relax while I do this. So that's one. Just put that back in there again. I'll show you that in a moment. And the second one, this way. Now I have these loosened already, just to make it easier on camera. So that's both out. So that housing now splits like so. Just leave that aside. Again, beautiful parts, you know. These are actually titanium. There'd be a high class titanium, what is it, 6AL 4V, something like that. I'm not sure on the grade, but something like that. Beautifully machined. Fabulous parts. Very lightweight. There's nothing to them, you know. Now these mount on O-rings, would you believe it? Just to provide. Put that on there and you'd see it again. If I can just locate it on, like so. So you can see the O-ring when they clamp there like that. Hopefully that focuses. It's clamping on the O-ring, which just provides a small bit of dampening vibration. When that's vibrating like that, when the engine is vibrating, it doesn't transfer as much to the pump, so it just breaks that vibration a small bit. But again, fabulous, you know. The O-rings are just normal. They're on a square housing, so we leave those aside. Again, now these were drilled out just to try and get this bearing out, but in the end I didn't bother. You can see there where I just tried to drill it. I just stopped. There was no point in ruining the pump for a video, because these are in with Loctite, and to get these out, as you can see, the torque is fairly high, but the hex head is very small, and in the data sheet they do say to drill them out, but I just stopped. There's no point. You'll see why in a minute. But moving to the back side. So what's going on here? The pump is self-regulating, if you want. When the line pressure reaches a certain pressure, the pump will actually stop pumping. It'll just go to neutral, which I'll show you how that works in a moment. But it's very clever. The pump inside has a Swashplate and pistons, axial pistons, which are controlled with a Swashplate, which is variable, which controls basically the line pressure. Now, the line pressure is the pressure in the whole hydraulic system of the whole engine, and once it reaches that pressure, there's no demand, the Swashplate will go to neutral. So it'll keep turning, but it'll stop pumping, it'll stop displacing. So that was very clever. How that works is there's a valve in here which is directly controlled by the pressure of the pump, and it controls the Swashplate angle, which I'll show you in a moment. So we'll pull off the back and have a look what's going inside. It's insane, but you'll see that in a moment. So these are just caps for transportation. You can see that they're just an O-ring with a backup ring, nothing too special. Now this is I should say this is the flow in here from the tank, or from the supply, and this then is the pressure side, which is threaded. All right, now they're in I think they're AN8 or AN6 or something like that. Now there's obviously ports here as well for taking off, you know, various things and all that off the engine, but what we'll do is take off this first and have a look what's going on in here. Now again, these pumps are the same on the back, so I'll just remove this, and this should hopefully come out like so, like that. So that's that part. It's like a fork part. This is titanium. This part here is held in just with a fork, which locates in here. Again, the larger one normally is the supply, which you can see there. Again, I know it's not, I know some of you hydraulic guys are cringing now. These pumps are written off, you know, it's not a clean room environment, so I'm not trying to pretend everything is spotless, but it's just to show the video, you know, these are written off, they're not going to be used again. So that's your supply, that's your flow out, your pressure. All right, so again, simple enough, casting, aluminium, nothing hugely special there. This is where the valve system is to control the Swashplate angle, which I'll get into in a moment. So what we can do now is we can pull off these, which are, I just swap this Allen key, which are these ones here, not those. So again, 4 Allens, which hold on the back plate. Again, custom machined, they're not off the shelf. And there's no washers either, which is something to note. This is probably going to be a slow enough video, but I just decided to do it all in one pull because there's no real need to edit on this. I'll put a few pictures up online, or not online, on the video, just of the pump cross section and all that, just to get an idea what's going on inside as we get into it. Now again, they're not a new invention, you know. The variable displacement swash plates are used in even in agricultural machinery, you know, they're used a lot. Now these also, they're not unlike hydraulic motors, which would have a swash plate too. They're not dissimilar, which you can look up if you Google swash plate motors. You'll find out all about those, but we're just concentrating on the pumps at the moment. As I said, this one, just before we open this one has got an accumulator which works by, an accumulator is just a diaphragm, which this will be the pump here, and let's say this is the pump, alright, and you'd have, let's say that's the diaphragm casing here, and there's a rubber diaphragm inside like that, and there's a air supply here, which is this one here. Alright, so what you would do is you would pressurize this chamber here with air, normally nitrogen, and as the system builds up here with hydraulic pressure, this diaphragm would belly like that and pressurize all this system here and pressurize this gas. Alright, so what that is, it's basically, in electronic terms, it's basically a capacitor. So if the system requires a huge demand, like very quickly, which the pump can't keep up with, this diaphragm can flex back and give it a pulse of pressure that way, just before the pump catches up. So it's called an accumulator to accumulate the pressure basically, with nitrogen gas in here. And it's like when the actuators stop moving and the line pressure builds again, the pump will pressurize this diaphragm up here again, and it'll have a supply ready of pressure for the next time. So that's what this housing here is. It'll be like that. The diaphragm is you need a special wrench here to open that, to get the diaphragm in there, which I won't open because I want to keep that clean for other purposes, because this pump is fairly good. But that's what the accumulator is. But back to this. So if we take off the housing this side, so here we see an O-ring, which I'll put in there. So as you can see, the intake on this side, which is this window here, let's call these windows, and the pressure side, the outlet. Alright, now on the outlet you'll notice there's a drilling here. Now this drilling takes line pressure into a valve here, a little spool valve, alright, which exits here and enters here. As you can see, if I turn it back over again like that, it's taken the line pressure here out of that window. Okay, so your pressure comes up here, comes in here, out of that into this spool valve and out here. Now this spool valve is controlled by a spring and a preset pressure, which would be line locked with wire locks. These are opened. There's wire locks in here, which are like this. They're just stop them opening. Nothing too special there. Sorry, this side. You can see them there. Same thing. Alright. So in here is a little shuttle valve, or a spool valve, which constantly goes back and over with pressure. Now I don't really want to open this because there's nothing really it's just a spring and an axle. So this is controlled with the line pressure, as I said, and it governs what flow comes out here depending on line pressure. So if there's full line pressure, this is fully open and we get full flow out here. If there's no line pressure, this is closed, we get no flow out here. That's all you need to know really. A spool valve is basically just a valve like this, just in a drilling like that, and it's neck down here like this, like that. Fluid comes in here, it can go into this gap here around that small shaft and out again. Now if this goes that way, obviously the fat section is over here and it blocks that drilling and the fluid can't come in to go out here, and there's a spring here. So that's all that is. But it's the entire control for this unit, so we'll delve a bit deeper in here and you can see it in a moment. So here we have the back of the pump. Now if I take this and put that in there, you can see the pump turning. Alright, so that's pretty self-explanatory. That turns like that. Now what I'm going to do next is open these and delve in there a bit deeper, and you'll see some very, very high tolerance parts. Again, custom machined Allens. Now it's important to say that there's nothing hugely special about the materials in this part. This is a cast aluminium housing. This is billet machined. There's a few parts titanium. This is stainless. Nothing crazy. So that's those open. So we can lift this off now. So, before I delve in here, I'll explain this. So, as I said, the fluid enters. I'll just turn this over, it'll be easier to see it. The line pressure enters here, alright, which controls this piston here. Hopefully you can see that. So this piston can push out if there's line pressure. If there's no line pressure, this one will push it back. This is spring loaded here, as you can see, alright. So if there's no line pressure, it's at 0, okay. And as the pressure builds, this pushes out, which controls this tab here, which is the swashplate angle, which you'll see in a moment. Okay, so just go through that again. So you should hopefully see that there. So that's the bit with no line pressure. And as the pressure builds, this comes out and it changes that angle here, pushes that tab over and pushes that spring, this spring loaded. Okay, so that's that part. Again, nothing hugely special. Aluminium, it's nearly all cast surface, machined in a few spots for datum, but nothing crazy. So we leave that there and we get to the proper meat. Again, all line locked. This is a hugely critical part. Can't open, can never come apart. If it does, it's really bad. Not so much in Formula 1, but these pumps are the same in aerospace, as I said. On the 777, I'm sure you've been on one, or the 320, which is a common Ryanair plane. F-16, I doubt many have been on one of those, but highly critical part. If this breaks, people die. That's just the way it is. So let's pull out the magazine, for want of a better word, and have a look. So here we go. Now, what about that? So these are the pistons, and let's call this the cylinder head. I think it's called the cylinder head in the by Parker Hannifin. I'm not sure what it's called by the service engineers or whatever, but let's call it that. So you can see the part like that rotates. It's a bespoke bearing. Again, crazy high tolerance. Spline drive from here. Beautiful part. I mean, look at that. Fantastic. But again, not unusual. I mean, there's farmers looking at this and they'll say, well, yeah, we've seen one of them before. In machinery and all that, yeah, I get that. But when you move into aerospace, it's a whole different level of tolerance and of it can't break, you know. So it's a nice part, you know. Again, roller bearing that sits on. Beautifully machined. Seriously high finish on everything. So that's that part. So there, if you imagine this like an engine, there the pistons going up and down, and they're the cylinder boards, which you can see there. And your bearing then gets pressed onto the outer wall of this. I can see a name. I remember calling a name. Yeah, it's a fag bearing. So yeah, they know what they're at. So what's going on here? Well, this is when this is on here, it's constantly encased in oil, which is the inlet pressure. All right, so there's zero pressure. It's just swimming in oil until it gets compressed. It's called the case pressure. So as you can see here, well, let's go back to this part again. This controls the swashplate angle, as I said, which we can see here, hopefully. So as the pressure comes in here, it moves that piston out, which changes the angle of this. All right. Now, once I take that out, you'll see what that does, hopefully. So let's take out these. Now these again were drilled out. They couldn't be opened. They're in with Loctite. They're like a 2.5mm Allen key. They couldn't be removed. So I just drilled them out. As you can see, they're just plates that hold them in, which was the plate that was falling out at the start of the video. Hopefully that one comes out as well. Now again, they're nothing too special, just they feel like steel by the weight of them, stainless or something like that, with an O-ring to seal them in. They hold in the swash plate. They're the pivot point for the swash plate. Alright, and if I remove the swash plate, which I should be able to do, I just remove that spline and the spring, and remove that swash plate. Hopefully it should come out. Should. That race comes out as well. Come on. Again, tolerances that are very, very tight. Will come out. hopefully. This is the awkward bit on YouTube videos, where you think everything will be fine. Oh, it'll just come out. Oh, there we are. Excellent. So, what a part. So, here we have the Swashplate. Alright. So as you can see, there are hangers which locate like that and like so. So they can hinge like that. Alright. That can hinge. Now, if I just insert this in here, you'll get a better idea of what's going on. Again, YouTube video moments. Again, tolerances are very, very tight. So just bear with me for one moment. And hopefully I won't have to stop the video, because I'd like to do it all in one shot if I can. Hopefully. Are we in? Where? Huh. So, again, now, excellent. So when the pump is at neutral, or there's no demand for flow, it's like that. Alright. So there's no axial displacement happening with the pistons, which you should hopefully see there. There's nothing moving at all. They're just all keeping, I don't know what's the word, equal volumes in the bores, like so. Alright. But they just came out. They just would, wouldn't they? Let's try that again. The joys. This is the bit when you're lying back in bed, going to sleep, watching a random YouTube video, and you're going, what happened? Where's he at? Yeah. There we go. So, when they're parallel, nothing happening. Alright? But when it's angled, you can now see they're moving through an orbit. So these front ones are at the top of the cylinder head or cylinder bore, and these bottom ones are halfway down the bore. So as this turns, they're moving up and down the bores. Alright? So that means that if you apply this manifold on the front of them, as they go down the bore, they're at the full bore here, top of the bore here, but as this turns, they go down the bore, they take in oil into the chamber, alright, and as they come around again then on this side, they're pushing out the oil, which you can see there, hopefully. So that's how it pumps. And once it reaches line pressure again, this piston shoots across, or sorry, this spool valve shoots across, puts pressure in here, moves this piston across, which is that guy there, which moves this, which moves that to equilibrium, and nothing is happening. So there's no power being taken from the system. So it's basically in neutral. It's still spinning, still engaged, but in neutral. So that's how that works. So that's a very cool part, very small, and a huge amount of power delivered in terms of work, you know. Now let's move on to that's the outer bearing shell for this bearing here. I can pull that again now once we're finished. Now one thing to know with these is they're hollow. Now that's to save weight, and it's also there's oil in front of these, so oil gets pumped down here with the pressure. It gets pumped down to the buttons and it oils them at the interface there, which hopefully I can show you. I don't think you'll be able to see in there, but oil gets pumped in there, pumped down along there, into the button, and it oils that interface. So there's a nice oil film there under pressure at the swashplate face. So that's how that works. Again, specialized bearing in there. You can see how it's put together. There's a very special wrench on these 3 points here, and again it's crimped in here to stop it opening. It's threaded in. It would be held there with a C-spanner on that outer, so you'd hold it here on those inners and here with the C-spanner, and it's swaged in here to stop it opening. Again, critical part. If this comes apart, if it opens, people die. Not in Formula 1, but certainly in aircraft. It's super critical, you know. But if you watch some of the air crash investigations on YouTube as well, there's some very good series on there that show you about failures and all that. A lot of the time it's hydraulics, and the main reason is, just for a moment, if you have an aircraft, let's just draw a very rough aircraft here, and very roughly the wire would work. Normally on older aircraft with the flaps here, hopefully you can see that in the camera, you can, with the flaps here, there would be one of these pumps controlling each flap, let's say the forward flaps or the ailerons from the back or whatever like that. The landing gear here at the nose, the wing landing gear, there'd be a pump on each location like that, or sorry, there'd be a central pump or maybe two, and there'd be hydraulic lines going to each part like that, up here, up here, up here, and off here. If only the wire would work. From one central pump. And the problem with that, it was fantastic, lightweight, one pump controlling everything, like I guess the electricity supply coming into your house, supply everything like that, from one source. But if, let's just say this engine exploded or something happened, it cut this line here, you'd lose all your pressure on all the lines from this pump. Like if you cut an archer in your leg or something like that, the entire system would just bleed out. But what they're doing now is they're actually doing electro-hydraulic systems on each part that they need it on. So there'll be a pump there, pump here, pump here, pump here, pump here, pump here, pump here, pump wherever need them, and then an electrical supply going to each pump. So, and if one gets severed or taken out like that, that pump is just gone. These are not affected because they've got their own supply. So they're all modular units. So that's an advancement of late. They're not relying on the one arterial system, which is a good thing, I guess. But yeah, that was a bit of a tangent, but let's go on to the housing again. So this all runs on, as you can see, another spline, which is a nice part again. So that's spline as well, and that fits in there. Now the purpose of this spline is to allow any tolerance stack up. So this is the drive here, okay? Now if I just get our input shaft again, you can see that goes in there. That drives that. Alright, just to a normal bearing, there's nothing too special about that bearing. That drives that. But if this was fixed to that solidly, you could get a bending motion, which wouldn't be good. So to counteract that and let this float on its own shell, they put a secondary spline. Hopefully that'll lock in there, which it should. So that can float just a very small bit, if that would seat. That's it. So there you go. So that can float like so on that spline very slightly to allow it to again seat up against the cylinder head, which is this part here, flat, and sit in its race without being told what to do by this shaft, so to speak. So that's the pump, and that's basically it. Hugely important part. Can be driven by any engine, as you can see, aircraft, Formula 1, I'm sure it's in other things as well. But again, it's not been changed for a long time, this pump, by Parker Hannifin. It was a fantastic design. It's pretty weighty, off the top of my head. It's about 7 kgs, I think, like that. Again, AP 05V. Same on that. AP 05V. So per rev, just to mention it, per rev, it is, sorry, I just have to think. It's 2.57 litres per minute, which is 6.8 gallons. Sorry, I'm just looking at the notes here just to get them right. And line pressure is 3000 psi, which is 206 bar, and per rev it is 0.15 of an inch cc, or not cc, but 0.15 of an inch delivery volume, and cc it's translates to 2.46, and the maximum speed is 11,000 rpm. So yeah, so that's pumping. It can pump 25 kgs of fluid per minute, which is impressive, you know. But hopefully that's it. Now, I said I'd get out a video every Tuesday. Now it's not Tuesday, as you can see, but I just want to try and keep it consistent enough when I can. But next week I'm going to do the video on scavenge systems, so hopefully you'll enjoy that. So I'm going to end it there. Pretty late, pretty tired, as you can probably hear, but I hope you got some information from that video, and we shall talk again. Take care, folks. Good luck.